All right, hey AP Chemistry. I wanted to go over some of your pre-lab questions for determining the molar volume of hydrogen gas lab. Now, I'm not going to go over question number one because if you want the answer to it, it will be found in the background under the first couple of sentences about how to answer this question. I'm also not going to go over question number two or three. Question number two asks you to figure out a formula by combining particle diagrams evenly. You're going to have to do that by circling and combining. I'm going to leave that up to you. And then finally, number three, I'm not going to go over because the purpose and how you're going to do it is going to be found in your experiment overview. What I want to focus on this video is doing some of the most important calculations, which would be questions 4 through 7. Now, you're going to have to remember how to convert moles to grams, and you're going to have to use any of your notes on gases to answer questions 4 through 7. So for number 4, and I'm going to set us up. I'm not going to do all of the calculations. I'm going to set you up, and it's going to be up to you. It says a reaction of 0.028 magnesium reacts with excess hydrochloric acid, and it generates 31.0 milliliters of hydrogen gas. The gas was collected by water displacement in a 22 degrees Celsius water bath. The barometric pressure in the lab that day was 746 millimeters of mercury. All right, it says use Dalton's Law and the vapor pressure of water at 22 degrees Celsius to calculate the partial pressure of hydrogen gas. If you remember from our notes, if I collect a gas over water, the total pressure is going to be equal to the pressure of my gas plus the pressure of water. This is my barometric pressure. This is my pressure of the gas. And this is the vapor pressure of water at a specific temperature. And now this comes from Dalton's Law because the sum of all of the individual gases will equal the total pressure, which is the barometric pressure. Now, it already told us in the problem that the total pressure, P total, is equal to 746 millimeters of mercury. To look up the pressure of water, you're going to have to go to page 4 of this lab report and see, okay, it says it was 22 degrees Celsius, so the vapor pressure of water is 19.8 millimeters of mercury. So pH2O is equal to 19.8 millimeters of mercury. I'm going to leave the rest up to you to solve for P of H2. You're going to plug in P total, which is my barometric pressure. You're going to plug in P of H2O, which is 19.8, and solve for pH2. If you do this math correctly, you should get a P of H2 is 726.2 millimeters of mercury. So make sure you did that math correctly. And then for number 5, it says use the combined gas law to calculate the corrected volume of hydrogen gas. Now, to remind you of the combined gas law, it's P1V1 over T1 equals P2V2 over T2. We're not going to throw N in here because the moles are going to be the same on both sides. I'm creating and using only a certain number of moles of hydrogen gas. And it says it wants it corrected to STP. That means my P2 is going to be 1 atmosphere, and my T2 is going to be 273 Kelvin. This is STP. And so I don't know what my V2 is. I'm looking for my corrected volume. My P1 is going to be the pressure that we just calculated in the previous step. So 726.2 millimeters of mercury. My V1 is what was collected in the lab that day, which was 31 milliliters. And then my T1 was the temperature in the lab that day, which was said it was 22 degrees Celsius. Now, a couple of things. My pressure and temperature for my STP is in atmospheres and Kelvin. I want to convert either or. I want to make sure that my units are the same on both sides for pressure. Temperature always needs to be in Kelvin. So for Kelvin, I add 273. My temperature in Kelvin is going to be 295. To go from millimeters of mercury to atmosphere, there is 760 millimeters of mercury in 1 atmosphere. So to convert, I'm basically dividing by 760. Prove to yourself that you get a pressure of 0.956 atmospheres. And now all you're doing is plugging and chugging these values into this equation. I'm going to leave this here, but you are putting these values into here and solving for V2. To check your answer, your V2 should be lower than 31.0. I'm not going to give you the value. You're going to have to calculate that, but you should get lower than 31.0. And then for question 6, it says, what is the theoretical moles of hydrogen gas using the correct balanced chemical equation? Mg plus 2HCl yields MgCl2 plus H2. This is a throwback to summer work and stoichiometry, and we're going to go back to stoichiometry in Unit 4. But don't forget that I could do a BCA table, or however you want to do it. It looks like for every 1 mole of magnesium, I get 1 mole of H2. So my moles of magnesium are going to be equal to my moles of H2 according to this balanced chemical equation. If I do the math on the side, don't forget that convert these grams to moles. 0.028 grams of magnesium divided by 24.3 grams per moles of magnesium. Don't forget that 24.30 is the molar mass of magnesium. I get 0.00115 moles of magnesium. I'll put that here in the beginning of my BCA table. 0, 0, if I'm doing BCA. Just a nice little organization way. Before the reaction occurs, I have no magnesium chloride and hydrogen. And I'm going to say that HCl is in excess. And then subtract 0.0115 moles. This is a 1 to 2 ratio, so I need 0.0023 moles of HCl. 1 to 1 ratio, I get 0.00115 moles, 0.00115 moles. And in the end, I'll still have excess HCl. I should have no magnesium left over. Note, Mg should be used up completely. If you still see some magnesium ribbon in your reaction, this is going to affect your data here. And so I'm going to have 0.0115 moles of MgCl2 produced and 0.0115 moles of H2, which is what this question is asking. Now, I did a lot of extra work, and you could have just been like, okay, moles of magnesium is equal to moles of H2. So as soon as you get this number, it's equal to that one. And then finally, it says divide the corrected volume of hydrogen by the theoretical number of moles of hydrogen. Okay, so my volume that you got corrected, if you're continuing watching this video, you should have got 27.46 milliliters. That was from question number 5. So if you did question number 5 correctly, I don't know where I put that paper, but if you did question number 5 correctly, if you did question number 5 correctly, you should have got 27.46 milliliters here, which is lower than 31.0. And then the moles that you calculated is 0.00115 moles of H2. Now this volume needs to be in liters. I'm going to do dimensional analysis. 1 liter is 1,000 milliliters. So basically I'm dividing by 1,000, 0.02746 liters. And so now I have my moles, I have my liters. It says divide the corrected volume by the moles. Molar volume will be equal to 0.02746 liters over 0.00115 moles. And you get an answer of 23.9 liters per mole. And so this is the molar volume, or the volume of 1 mole of that gas. So I need you to know these major calculations in order to do a bulk of the lab. There's going to be other side calculations that you need to do and other measurements that you need to collect to get here, but make sure you know how to do questions 4 through 7, because those will be your major calculations for this lab report. So to quickly recap, you use Dalton's law to get the pressure of hydrogen. You want to correct for the volume using the combined gas law. and then you get your moles, and you plug into volume over moles will give you my molar volume. Alrighty, if you have any other questions or concerns about your pre-lab, please let me know. Make sure you know this for your pre-lab quiz.